So in this video, we're going to be talking about Euler's totient function. And this is a really useful function, and its formula is also pretty useful. And yeah, and the main purpose of this video, purpose of making a video on this function is because there's another video on the Euler's totient theorem, which is a really famous number theory theorem, and it uses this formula, of course. And therefore, yeah. So after watching this video, I strongly recommend you to go over to the Euler's totient theorem video and look at what it is. So today in this video, we're just going to look at the formula and how to use it. So Euler's totient function. So Euler's totient function is written as phi n. It's written as phi n. And this denotes the number of positive integers less than or equal to n that are relatively prime to n. So if you don't know what relatively prime means, it means that the GCD of the number and another number is equal to 1. So for example, like 3 and 4, the number 3 and 4, they have a greatest common divisor of 1, so they are relatively prime. So what this function is asking for is the number of positive integers from 1 to n, so less than or equal to n. So the number of integers from 1 to n that have a greatest common divisor of 1 with n. So yeah, that is Euler's totient function. So let's try just get an idea of what it is. So totient of 12. Let's look at what totient of 12 is. So let's look at all the positive integers from 1 to 12 first then. So 1, it has a GCD of 1 with 12, so yeah, it works. 2, it has a GCD of 2 with 12, so it does not work. And 3, again, it's a factor of 12, so it has a GCD of 3 with 12. And same as 4. And if we keep going on, I'm just not going to do all of it because it takes a long time and it's repetitive. So if we try all the values from 1 to 12, then we get that 1, 5, 7, and 11 are the numbers that are relatively prime to 12. So yeah, and that's 4 numbers, so totient of 12 is equal to 4. Yeah, and so we know what this is now, but if we want to find the totient of a really big number, then we don't want to just look at every single number from 1 to that number. So what we're going to do is we're going to look at the formula for this function that will make computation much easier. So the formula is, my handwriting. Let P1, P2 up to Pk be the distinct prime divisors of n. So let P1, P2 all the way up to Pk be the distinct prime divisors of n. Then the formula, with this, the totient of n is equal to n times 1 minus 1 over P1 times 1 over 1 minus P2 all the way up to 1 minus 1 over Pk. No space. Okay, so actually let's just make that a bit neater. The k is a bit unclear. There we go. So yeah, it's a pretty neat formula then. So you just have to find the prime divisors of n, which is pretty easy, and then you just multiply these numbers. Using them, you just multiply all these numbers together. So yeah, that's the formula. And if you're wondering about the proof, we're not going to discuss it in this video because it requires some more advanced techniques. But yeah, that will be covered in another video in the near future. So yeah. So we just have to know the formula in fact for now. So let's try to test it out.
Let's try test it out then to see if it works. So we know the totient value of 12 by already bashing it. So let's try see if we get the same result if we use this formula again. So totient of 12. Okay, so actually before we do that, we need to prime factorize 12. So 12 is equal to 2 squared times 3. Oops. Is equal to 2 squared times 3. So its prime divisors are 2 and 3. So by the totient formula thing, we get totient of 12 is equal to 12 times 1 minus 1 half times 1 minus 1 third. And that gives us 12 times half times 2 thirds, which is equal to 4. So we can see that this totient formula actually works. So yeah, so for now, just know, so from this video we covered what this function actually means and a quick formula for calculating its value. And yeah, if you found this video, and yeah, this function is pretty useful too in many number theory problems. So yeah, make sure you remember this formula for the totient function. And yeah, if you found this video pretty interesting, then I strongly recommend you to go watch the Euler's Totient theorem video, because that theorem is really famous in number theory and it uses this formula. It uses this function. So yeah, just have a look at that video too. And so yeah, hope you enjoyed this video and see you in my other videos.